I'm Grant Dasher. I'm a software engineer at Google. I work on one of our identity and our identity management and security products, and I'm going to talk about our strategy for what we call context-aware access, or leveraging Google's BeyondCorp visions to protect your applications. I don't know if all of you have seen the whole trifecta of presentations today, but I'm going to try and target somewhat slower than Christian spoke. I have a habit of talking quickly, but I'm going to try and moderate it. So, if I get talking too quickly, it's just because I'm excited, because I think this is cool stuff, and hopefully y'all will think it's cool stuff too. So Amit and I are going to share this presentation. I'm going to sort of start walking through the beginning of the presentation, which is basically talking about how the network failed us and how we have sort of discovered the need to move beyond a network-centric approach to security. Then Amit is going to pick up and talk about how identity and context information can help rescue us from this situation that we've dug ourselves into. And then finally, I'm going to come back up here and talk about our own internal technologies. You heard a little bit about how Netflix addresses this problem in the previous talk. I'm going to talk in some detail about what we do and what we're offering as part of our cloud platform. But really, that's not the focus of the presentation. The focus here is just on the intellectual content, like why do we think this is a good way of approaching security infrastructure. So the network has failed us. I think, for us, the realization really came in 2008. These days, there's state-sponsored attacks, whether it's Russian disinformation campaigns or Russian attempts to compromise political organizations, Chinese actors, North Korea, Iran, all sorts of governments around the world are attempting to access the data of other governments, but also increasingly private enterprises. But in 2008, this really hadn't started happening yet. But a hacker group called Operation Aurora targeted 20-plus tech companies, including Google. And it was, I think, demonstrated in the press that this was clearly a state-sponsored attack. They were trying to compromise tech companies because, we have important user data. And it really sort of made us realize that the threat landscape had changed. It changed for Google in 2008, and it's now changing for everyone else. Right? These attacks, I think what we've seen in the last couple years is that these attacks have really moved from just being something that nation states and top tech companies have to worry about to something that the entire industry has to worry about. Because everyone has data about their employees, everyone has business sensitive information, and the collection of all this data can benefit state actors and even non-state actors to achieve nefarious purposes. SaaS email systems were the target of the attacks, but there were essentially two primary causes of failure. One is phishing, and the other is issues with the integrity of the endpoints. And the network, this is really illustrative of what the network problem is at the end of the day. In the traditional model where the network is trusted to provide a security boundary, you end up in this situation where you have your endpoints commingled with your secure data inside of some perimeter. And there's not typically segmentation between the sort of low security endpoint devices and the high security sensitive data. Sometimes people will try and create internal firewalls and they'll have like levels of perimeters and stuff like this, but it turns out to be really difficult to make that actually manageable. And so you end up falling back to a sort of single security perimeter with your endpoints inside of that. Unfortunately, the endpoints are really easy to compromise. And so if you compromise the endpoints, you get inside of that security perimeter. And then similarly, to get through the VPN, technology like OTPs was being used. And as Christian demonstrated pretty extensively in his presentation, OTP technology is phishable. And so, you can phish credentials of an employee, you can escalate your privileges, and then you can maneuver laterally because inside of this perimeter, there's not really lots of internal security and authentication controls. And part of the reason why it's easy to cross over that perimeter, or easier than it should be, is just because managing the perimeter is difficult to scale, right? The tools that you have in your hand, think about it, you have really bad tools. You have ports, you have IP addresses, you have some of these next-gen firewall products which introduce sort of weird concepts of authentication and identity into the network protocols that are, decades old and weren't intended to do this, and they typically come with pretty substantial cost in terms of trying to deploy a next-gen firewall in front of your application, so you can't scale your traffic past a certain point. And then mobile, right? On the mobile devices, there's increased demand for employees to be able to use mobile devices, and the VPNs on a mobile device don't really interoperate well with all sorts of things. And then of course the growth of SaaS applications, right? The applications are sitting outside your VPN and now increasingly the cloud. So all these things are sort of coming together. And while people are looking for increasingly creative ways to reverse engineer the network perimeter around the cloud and around their SaaS applications, you have CASBs and you have VPCs and you have all this technology. And it does provide some useful security properties, but at the end of the day, you end up punching a lot of holes in it in order to make your application workloads work. And so we concluded that really we needed to rethink the way that you did security in order to make it more effective in this new world. We wanted to deprivilege the network so that it wasn't about crossing one network perimeter and then getting ambient access to applications based on lower security authentication primitives. We wanted to basically shift the endpoints outside of the perimeter, deprivilege the network, and then require full strength authentication with respect to every application access. And the reason we did that was we just thought that security posture was much easier to defend in a cloud-centric world. Rather than punching a bunch of holes in weird places in order to make things work, you sort of redesigned the perimeter in a way that we felt we could actually defend, but also would enable mobile, would enable cloud-centric, would enable API-centric, would enable web-centric use cases, and fit in better with that model rather than trying to reverse engineer all those technologies into 30-year-old networking primitives. And so, instead of having an egg with both your endpoints and your applications inside of it, the goal is, some people say put your applications on the internet. I like to think of it as take your endpoints outside of the trust boundary. Try and reduce the surface of your trust boundary to be as small as possible, so it just wraps around your applications using like a reverse proxy, but it doesn't include your endpoints. So the endpoints themselves don't have any ambient authority. So the principles of how to make this work is you deprivilege the network, you don't trust the network, and then you make sure that every request is encrypted, authenticated, and authorized. So you shift the security perimeter to application access rather than network access. And that new perimeter is more defensible in a world with SaaS and mobile and cloud and all these other things. And because it's up-leveled to the application level instead of operating at the network level, you suddenly get a lot more technologies that you can use. You can use identity, you can use redirects, you can use all of these things that you really hard to inject into the network. Despite the valiant efforts of some very smart people, it's been very difficult to try and inject those concepts down into low-level networking protocols. So even our source code, right, for our important repositories, I was just looking at some source code a few minutes ago as part of doing a code review. That's on the internet, in a sense, but it's okay because every access is authenticated, authorized, and encrypted, so it's still secure. So Meet is going to talk in a little more detail about the components of this from a sort of theoretical point of view, and then I'm going to talk about in practice how it gets deployed.
So one of the things I want to stress here is that these next 10 slides have this tendency to come off as holier than thou, and I want to make sure to make it clear that it's not. It's not that we got this all right from the very beginning. I'd like to say, if I could subtitle this, and I could have subtitled it, so I should have, was learn from our mistakes of the last 7, 8 years, right? And that's kind of what we're trying to present here. We walked this model of, Grant did a great job of laying out why we're moving away from a network-based security into something beyond that. No pun intended. And so what we're trying to do is highlight all the things that we needed to do. And if anyone who saw the Netflix presentation before this, it was kind of cool to watch that because it was sort of the same story, but it was best to breed, right? They had their own stethoscope in some cases. They used us for identity. They used Duo for MFA. Nothing has to come from one vendor, and that's sort of the beauty behind the situation here. So this is really a generic walkthrough of how BeyondCorp works for us. We can take questions. So having said that, with all my caveats, I think that, well, we'll talk through what the flow would look like for us, but there are three key attributes, or three key principles that we need to follow here, and hopefully just keep reiterating throughout the presentation. You'll say, Amit, I buy that you're not using a network, but then what do you do to make access controls? And we think of it in three simple ways. The first is know the attributes of the request itself. You could know so much about what the user is doing or their intention of what they're trying to do based on machine learning and other kinds of things. You can start to see the health of the user, the health of the device. Use all types of attributes in making access decisions. The second part, and I think this is really key, is create simple defined and easy to scale policies, right? For those of you who use like rich firewall kinds of products, you have all these rules defined in there. I think those are amazing. I think they're very hard to scale, right? You have thousands and thousands of applications. How do you move from a world where you have a centralized policy place and be able to apply these at your application endpoints? And last, and this was really a big learning that we had at Google, is you have to kind of classify all the types of apps and all the data that you have within the boundaries of your enterprise. So I think Jonathan gave a great example if you were here earlier with Netflix. There's a cafe menu. If that leaks to the world, it doesn't destroy your quarter. But there are source code repositories and other really business critical things that are that could end the corporation, right? And so what we need to do is categorize these things into different types of what we call trust tiers. Something is extremely business critical. It has much stricter requirements to get to. Something is cafe menu. If it leaks, it's okay. And so I thought in order to set up this story, it kind of helps to walk through a typical flow. And for those of you who've ever surfed the internet, this should not be surprising, right? You have an employee who uses a device, gets basic rules applied against your application request, and then you have a gating place in this case that says, can this employee, let's take me for example, can Amit access these systems? And in some cases you see that I can, because I have all the right criteria. In this case, this employee can access the ERP system, but it's denied access to CRMs, and maybe even access to storage bucket APIs, and we'll talk about all these things in detail. But that's the typical workflow that we see with BeyondCorp. This is the workflow we want for users to be able to access, right? You'll notice there's no VPNs, there's no OTP, all these different kinds of things. We try to simplify the process for the end user so we can provide extra security with hopefully less, oh great, the slide built up perfectly. So let's talk about what the risks are in each of these categories, right? So the first one is, we talked about the identity, but and I'll tell you things that we've publicly announced at Google. The biggest attack vector we found on any security system is the end user themselves, right? I think it's probably beating a dead horse, but the end user's credentials are the #1 attack vector that people use to get into corporate systems, right? And that's the first place you have to address all of your focus on solving security access. The second largest vector, can anyone guess? It's devices, right? It's malware, and we at Google, I think we publish it all the time, find random malware all the time on corporate devices. You need systems in place to be able to identify that things are out of date, so you can fix those problems. The other one is that you need to, Grant mentioned encrypted, everything needs to be encrypted. That is definitely a mantra we use at Google internally. We think the network path is an incredibly sensitive area you need to focus on. In fact, I was reading a stat I think Google just published that said of the top 500,000 websites in the world, 16,000 still use a version of OpenSSL that is at risk for heartbleed, right? These are things that are just still out there despite all the known risks. Rules engines, right? You need it's too easy to overprivilege a user or underprivilege a user, which means the security admin is constantly trying to debug why somebody doesn't get access to things. And then we have a proxy. We're saying get rid of the VPN, but you still need a way of checking all these attributes that we're talking about and determining, does somebody have access to a system, right? And so putting these proxies in place is itself a risk, right? And as we move to the cloud, one of the things that we found is that APIs have become public, right? If anybody stores anything in a storage bucket from any cloud vendor, that API is on the internet, as it should be. But how do you provide enterprise-level resource protection on those APIs, even though they're public APIs? And these are new attack vectors that we're finding as everybody shifts to the cloud. And so it should come as no surprise that for each of these things, the BeyondCorp story has, in fact, a solution or a way of attacking these problems, right? So of course, everybody here believes in a strong identity system. That's why you're at Identiverse. But the second part of that story is definitely some sort of strong auth, right? If you were here for some of our earlier sessions or you've listened to any of the keynotes, we believe very strongly in this U2F FIDO kind of model, right? That you have to have anti-phishing or phishing-resistant kinds of methodologies. and I think we've talked about that in great detail. Throughout the conference, I've seen a lot of sessions on device management, and Netflix themselves talked about their own, I think, stethoscope, they call it. I think these are the kinds of things that you need to have, and I'll talk into each of these in great detail, but I just want to overlay the risk with the solutions that you need to look at all these things. There's a device management component to all of this, right? You need to be able to know, what is the status of that device? Is this really my corporate device? Can I trust this device? Of course, we talked about well-configured TLS. One of the things that I think it took Google a long time to reach the conclusion of, but we've now fully bought into this idea internally, is this idea of a central policy engine. There must be one place where a SecOps person, a security operations person can come and define rules and change rules and have it propagate across the thousands of applications that are being protected by it, right? You must have a system that can scale, because you're not doing 3 and 4 applications, you are doing thousands and thousands of applications. And lastly, you need a proxy, so you can do this rich access control. It can handle DOS attacks from anywhere in the world. You know, it can terminate TLS. And then the other thing, and I mentioned this briefly, is as these APIs are getting online, they're public APIs. You can shut down VMs. You can access storage buckets from any public API. You need a way of extending these rules to those types of public APIs as well. And we'll take time for questions at the end, so because I know I'm going through this rather fast. I'm not going to belabor the points on identity. You're all bought in on it. But I did want to point out some interesting things that Google discovered over the course of the last 8 years that I think would be kind of interesting to note. We're all bought into the idea that you need an identity system, a single source of truth. But the thing we found is that there are ways now you can use your SSO systems and your identity systems to start to build common patterns of specific users. So is it common for Grant to log in at 2 a.m. in the morning to check in code? Unfortunately, yes, probably. Is it common for Amit to do that? Absolutely not. And so these are kinds of behaviors that you can start to identify. And if Amit suddenly is checking in code at 2 in the morning, A, he shouldn't be checking in code, but B, why is he doing it at 2 in the morning? It doesn't mean that you have to stop that access. It means you can start to escalate the request, right? You can say, okay, as we talked, I think there was the word dynamic access was used earlier. We believe very strongly in this idea of dynamic access, and we'll talk about that. Again, we talked about OTP codes. They are phished. We've seen them. I think Google published a report late last year that said OTP codes are now equally and easily phished as much as user credentials are. And the last thing, and it really is a mantra here at Google, is every session must be short-lived. It doesn't mean that you're constantly prompting somebody to re-enter their credentials. That would become a very frustrating experience for developers and end users. It simply means that with a simple touch on your key, you're just re-authenticating that you are, in fact, in front of the machine. It is a live session, right? And so you can refresh that session. But every session should be short-lived, and so that if I turn my back on my laptop at Starbucks and then turn it back around and my laptop is gone, that is not an attack vector that's active for long. We'll talk about device inventory. I think there's a lot of MDM solutions that are out there. I wanted to go beyond just device identity. So at Google, we believe very strongly in associating Amit with Amit's device. And he can have numerous devices potentially. But to access really business-critical systems, you need some sort of healthy combination of Amit's device, Amit's location, whatever it happens to be. But there's a second angle to that, which I think is really critical. It's not just identity of the device. It's also the security posture of that device. And I know a lot of MDM systems exist out there. Hopefully you're using some, ours or somebody else's. But the key is that you're tying the attributes of the request, of the device itself, into your access request as well. Right? So things like, is my OS up to date? Am I running the right version of antivirus? You know, is my firmware, am I doing a firmware boot if I happen to have a device that does that? Is my disk encrypted? Do I have screen lock? So if, again, that Starbucks story where somebody turns their back on their device and comes back, I'm terrified my device is gone, but in 5 minutes or 3 minutes or whatever it happens to be, what is our internal one? Is 2 minutes? I think in 2 minutes we hit a screen lock, right? And that's a mandatory rule that we have internally. The one that I want to spend a couple of seconds talking about here is our access control engine, or what we use internally, right? What we believe is we've now talked about all these types of attributes that you've collected from a user. You know everything you know about the user. You know everything you know about their device. What you need to do is kind of, I'm using air quotes here, but score the request that's coming in, and it needs to be relayed against rules that have already been defined. So I'll give you an example of how we do this at Google. And again, if anybody's interested, we have these like rich PhD type papers on BeyondCorp on the website. There are probably dozens of them by now. So it's nothing I'm telling you is confidential. But at Google, we run a very simple model. We have, in essence, 4 tiers of access or trust, right? Something from most sensitive all the way down to not sensitive at all. And within each of these things, each of these tiers, we define very strict rules, but they're not overkill numerous rules, right? Think of something like if I want to check source code for search engine algorithms, right? Or I want to check my payroll. I can set rules that I must be coming in from a corporate IP block. I must be coming in from a trusted device. I must come in from a certain time of day. You could set these types of rules in a very simple, what we call maximum security trust tier, right? Versus I'm checking my cafe menu, I'm checking when the bus schedule is. Those can be open to anything, and all you need to do is coming from the geography of North America. And what we do with these simple tier creations, and in fact, I think I have one example on the next slide, you can start to apply these and scale against all of your applications. So it comes to the point now where the access control team is not the gating function. These are very clearly published rules that are put out there for all internal developers. And internal developers know, oh, I'm accessing information, I'm building an app that exposes financial information. I know what tier I fall into, so I know what I have to do to apply. We've had situations where developers have said, oh, I don't want to be in this restricted tier because it just makes it harder to get to this data. And they know what they need to remove data-wise from the application itself so they can down-level themselves. It's that's another way we get to a scalable model where we say the SecOps person shouldn't have to be having a committee that meets once a week to review your code and what you're looking at. We really try to make it a DevOps model where we tell the developers, here are the clearly published guidelines of what each is required in each tier. You decide what you need to do and where you want to be, and these are the rules that will apply against it once you reach that conclusion. So this is a very simplified example of what that means. In the papers, in that BeyondCorp paper, which is like 35 pages, they have much richer examples, but I thought it was important to highlight some of those things. And lastly, as Grant was pointing out, we like to say we put our applications on the web, and we do. I guess that's our tagline, so I'll repeat it. But the fact of the matter is that it's actually sitting behind a proxy, right? You need a proxy that matches the size of your infrastructure. It has to enforce all those rules that have been defined in the central policy engine. It needs to protect against DDoS, and it has to do global load balancing if that's the kind of environment you have. And then it has to use all those policies we talked about. The key here is, and the only way it really works is, you need to get to near zero latency with this. And it is possible with today's proxies that you use there. So you're checking identity. Identity is already there. You can just, and all the other contexts match. You grant access. If not, you don't. And often cases, you would explain to your end user why they're failing. I think in the Netflix example, it said, oh, your device is out of policy. You can go and fix that kind of thing. That's obviously the same model that we ourselves have pushed to our employees, that we want you to be able to identify what's wrong and fix it. There are other enterprises that say, no, I don't want to reveal any of my personal information. Here's the code, send it to your IT admin, they'll fix the problem for you. And so you can go either way. In fact, at Google ourselves, we've kind of gone through that balance ourselves. And so I thought, before I get off stage and give it back to Grant, who is the much more measured speaker, so to conclude, I thought it would kind of be good to highlight how this would work in an actual example. And these are actual how it works for a Googler, for example. So let's say you're at a coffee shop, you're on a public IP address, you are Joe, you are a member of the right admin group, so you've been given permission to access certain code. You're using your corporate device, so we know the serial number, we know the device is in a good state. We come to the admin rules, the application rules. The rules say, great, as long as you're coming from a corporate device, even if you're on a public IP block, you can access our bug system. Right, and so the proxy in this case validates that, and you're granted access to the bug system that we have internally. So think about it. If Grant wants to check in code or review somebody's CL, he can do that from a Starbucks as long as he meets the minimum requirements. I think walking through kind of an example where it doesn't work so much is kind of key to highlight how Google also fixes these other problems. So here's another example again where Joe is an admin, but this time he's using his personal device. We know nothing about this device, so we say, yeah, you can come in from a public IP address, but you need to come in from a device we trust. In this case, we don't, and so we're going to deny you access to this system. I think that's obvious and probably pretty standard. I wanted to highlight that example because I wanted to show you how Google tries to resolve that problem. In this case, what we say is, okay, again, the same request comes in as Joe's tablet. The admin rules are there, but we've now created these types of layered access or dynamic access, as it was called earlier, where we say, okay, this is Joe's tablet. We don't know anything about Joe's tablet, but if Joe is willing to use his U2F key and step up his access or give us other signals or other attributes, we can in fact still grant access to other systems. So in this case, he uses his U2F key. We don't in fact allow him to access the bug system because we're still worried about the device, but there are other systems he can still access even from his own personal device that he wouldn't otherwise be able to. In this case, his calendaring system. And so the goal here is really to enable employee productivity wherever possible, and when we don't have enough signals, make it richer so we can in fact do that. So I'll pause there, and I'll take questions later, but I'll give it back to Grant to tell you how to get started on this. Okay.
So just to set the record straight, I do not, in fact, check in code at 2 a.m. I'm I tend to go to sleep early too, but some people definitely do, and for those people, that could build a slightly different user model. Okay, so let's talk about getting started. So how do you actually deploy this in your enterprise? So part of it is about planning. It's important to identify the right apps and the right users, and you really get a catalog of your application. So if you've ever deployed SSO inside your enterprise, this is kind of a similar process from a procedural point of view, like collect a catalog of applications, figure out what all the different business units are using, what are their applications, just get a handle on the flavors of them. And you don't need to do every one from the beginning, but just get a sample, 5, 10, 15 applications, maybe a couple SaaS applications, a couple of internal applications, whatever it is. And then sort of try and understand the different use cases, right? Like, do we want to allow access to this application from anywhere based on device identity? Do we want to restrict application access to the corporate office? Not from a network security point of view, but from a business compliance point of view, because you want to, say, block access from certain regions of the world or whatever. So once you've identified a couple of candidate applications for your proof of concept, then you put those applications behind an authenticating reverse proxy. So Google provides such a product, other vendors provide it as well. And that reverse proxy in the beginning doesn't really do anything but provide load balancing protections, and then you can turn on authentication. And at the beginning, we sort of think people turn on authentication just using users and groups, right? Just make sure the user is authenticated. You don't need to do device identity or any of these more complicated rules or anything like that, just users and groups. Start there. And then the second step is, around privileged access. So on the privileged side, we think that it's important to use a strong credential with your privileged access. So if you have a PAM system or whatever that you're using, integrate that with an identity provider that provides strong cryptographic-based binding when you do the access, right? Google provides that in the form of U2F. Other vendors have other solutions, but we think that binding that identity to a hardware token is an important component of providing strength of authentication against sophisticated attacks. And then finally, roll out a sort of an approach along the tiering lines that we were talking about that leverages device identity, right? You want to sort of say, okay, I've got 2 or 3 kinds of applications. Maybe it's just binary. Maybe it's all applications get the same security in the beginning, but maybe eventually you want to have a couple of different classifications in order to differentiate the cafe menu from the sensitive corporate data. And you add in device identity, and you add in rules based on the device. Is there a screen lock? Is there are they on a corporate issued device? Are they coming from a device which has a certain up-to-date version of the operating system which meets its patch levels and so on? And you can add these security controls incrementally, and then once you've sort of classified the applications and figured out, okay, now I roughly know how many tiers I want, now I roughly know the picture of my applications, then you can really deploy this at scale. I think you'll find, as with most of these projects, after the first 10 applications, the remaining next 100 applications are probably pretty straightforward, and then there's a lag, there's a tail of applications which are hard for one reason or another. It took Google a long time to get through the tail, and I'll be honest, there's still a couple of applications that have some weird one-off because they're just weird. And that's okay, right? If you can reduce the threat surface by 90%, and the remaining 10% is not the most sensitive corporate data, you've made a huge improvement in your security, right? So you want to get to 100%, but you'd rather get to 90% than 0%. So don't let the fact that it's hard to get to 100% stop you from getting to 90%. Right. So, in terms of identifying the proof of concept, we think it makes sense to start with basic non-business critical applications, wikis, lunch menus, things of that nature. HTTP applications are the easiest applications, so start there. And then, of course, there's pretty limited RBAC needs in these applications. Maybe there's an administrator and then there's end users, something simple like that. Right? So you can do that using basic rules. Deploy the application to an environment where you can only access traffic when you put the proxy in front of it. So we talked about how this is about moving the endpoints to the other side of your security perimeter. It's important that you don't have a backdoor to allow application access to sort of go around your BeyondCorp controls. and using technologies like VPCs and security groups and firewall rules and things like that, which are now much simpler because you don't need to accommodate the endpoints, but you can use those technologies to sort of create a little cocoon around your applications. And then you turn on the simple, authentication logic. X user can access application. Start there, very simple, just identity-based, no fanciness. Then you want to move to the admin authentication side. You want to do strong authentication. We talked about this. I think that we talked about this at some length in the Christian session, so I'm going to sort of maneuver through that. But once you've done that, you can sort of turn up the screws on your proof of concept applications. You can add device identity using integrations with MDM or endpoint sort of products, things like Stethoscope, which is open source, or products from other vendors. Google has a product as well. Lots of vendors have products that sort of provide, CrowdStrike, that kind of thing, to sort of provide data to your identity provider about the applications. And then this talks about certificates. It doesn't have to be certificates. Some kind of device identity. You can use certificates with Wi-Fi because there's, radius certificate integrations with Wi-Fi is sort of a thing. So, we think that, that's one way to go. But then also, by collecting the inventory information about all your devices and your device identifiers, you can feed that into your access rules engine and use that as sort of a signal in this device classification. So I think that getting the device side of this right is the hardest part, but I think that this is the way things are going, and there are a number of vendors out there who are willing to help with the device side of this and sort of fit together the various pieces in order to give you a true integration between your inventory system and your access management system. And once you have that integration, you can say things like, this set of devices is fully trusted, and therefore those are the only devices that can access my sensitive applications. And you can take that to yet another level by trying to store those device identities more securely, by trying to store them in hardware and use asymmetric crypto authentication via something like token binding or TLS certificate. So there's increasing levels of sophistication that you can take here. But we think just getting the device identity is a significant improvement. And then, coming back to this slide, right, the key features of our internal deployment as well as our product are, identity, endpoint verification, rules engine, our identity-aware proxy product, and then our integrations with VPC and other sort of network level controls, and to provide other kinds of controls. So that's built into our GCP product. So as part of the Google Cloud Platform, there's a number of these components, but like I said, it's not just about that. There's lots of vendors out there who will provide you pieces of this, and everyone has to sort of stitch their architecture together in a way that works for their business. But we think it is possible. We've seen now several companies that have successfully made this transition and been able to sort of up their security game while maintaining usability. So that's where we're going to stop this a little early, but I'll take questions.
I have lots of questions. I'll start with one, though.
Okay.
When you guys do a good job of describing how you allow managed devices to have access to the most sensitive information, do you have aspirations towards any way that you can allow access to sensitive information from unmanaged devices, from that tablet or the kiosk machine somewhere? Do you have aspirations of getting there at some point, or is that not in the roadmap?
So it's not really a technical issue, right? It's a policy issue. So as a technical matter, the technologies that we're talking about here certainly can allow access to sensitive data from unmanaged devices. We've made a policy judgment as Google that we don't want to do that for our sort of security
But for
posture.
technical reasons, right? Because the devices may be owned and there may be someone screenshotting or some malware on the device or malicious user and
Right.
man in the middling it.
Right.
And I'm wondering if there are other technical ways that one could somehow obfuscate data, and I wonder if you guys are thinking about that. If you're not, that makes perfect sense. I'm just curious if you guys are thinking about that as a long-term.
Yeah, so I mean, look, our view of it is to the extent that it's not, for us, it's not so much about is the device managed or not. It's about do we have attestations that we trust about what's going on the device. So our view on this is more, yes, it would be fine for a tablet to access the data if we had attestations that we could trust that say that it's not compromised. And so, for example, on devices that have multiple security zones, like on a mobile phone where you have a secondary processor, which in theory is separate from user space code, that can make attestations about the device, then you can imagine feeding that data and making a different policy judgment. So I think exploring how to make BYOD useful is important to us because our employees want it. Well, we allow it on mobile, right, with certain caveats. But allowing as much access as we can to our employees so they can do their job is something that matters to us. But the way of getting the right attestations about the quality of the endpoint, that's a technically challenging problem that we're still working through. I mean, Android can do some of those attestations, iOS can do some things, Windows 10 can do some things, but on like a Linux machine where we give root to the engineers, which is what we do, we can't really attest to anything, right? So, yeah. And we can take more questions from you at the end if you want. But yeah, go ahead.
So, same question as for the gentleman from Netflix, and you insisted on the latency part of it. So, into the authorization process, there may be multiple or thousands of policies to check against for the request. What is your feedback or your magic to keep the latency very low when in a case where we have multiple policies to check?
Yeah, so I don't think there's actually thousands of policies to check. I think that the basic strategy is to try and pre-compute as much information about the devices as we can. So we know, for example, this device is trustworthy in a sort of request-independent way to the extent that's possible. And then when you're evaluating things at runtime, we have 4 tier classifications at Google. So even if those are complicated, you're talking at most, 20 or 30 sets of rules with some bounded complexity based on the pre-computed data. So yeah, at the end of the day, that's just not that expensive to compute. And then you can cache things a lot on subsequent requests, right? So I think in practice, the performance is not actually that much of a problem if you effectively cache things and if you pre-compute stuff and if you sort of bound the complexity of the evaluation you're trying to do.
Yeah, keep the rules simple.
No, I mean, they don't have to be simple, but they don't have to be simple, right? But they should be written in a way that is not sort of unnecessarily expensive. And I think the pre-computation and caching helps a lot. Go ahead.
What about communications when neither of the parties is an endpoint, like preventing lateral movement from server to server?
Right. So I think that's a good question. I think our view on that problem is actually a little different. So once you're talking about server-to-server communications, we're strong believers in binary authorization and similar kinds of technologies to make sure you're not running untrusted code on the servers. So in general at Google, it's an unexpected case for a human to be SSH'd into a production machine. Like that's super rare. And our production environment only runs code that's guaranteed cryptographically to come from our CI/CD pipeline, and we have a hardware root of trust in the server boot up, and then we have sort of strongly authenticated inter-network communication traffics on the servers. So those are sort of, that's the way we think about lateral movement. Like BeyondCorp is mostly focused on users administering infrastructure. And then once you talk about servers talking to each other, there's other security technologies that we tend to leverage to try and contemplate those problems. Does that make sense? Yeah. Okay, go ahead.
So at least in one of the diagrams, it identified that you're using the proxy to do SSL termination, which it would imply, at least, unless you're using another form of SSL behind the proxy, to like maybe you're using 4028 on the front and then a lesser SSL that's less expensive to re-encrypt on the back end. That means that the servers on the back end are actually getting clear text communications?
No, we just re-encrypt it.
Yeah.
We just re-encrypt it. We have our own internal cryptographic protocol for performance reasons, but it's it's the same. It's it's EC, it's EC Diffie-Hellman. it's Diffie-Hellman with elliptic curves, right? So it's cryptographically not really less secure than a normal communication is. But yeah, no, our recommendation is terminate it at the proxy and then open up another TLS connection from the proxy to the backend. Yeah, you definitely don't want to be sending unencrypted stuff to the backend. And with modern machines, the cost of a TLS session doesn't become a problem until you reach some enormous scale. And even then, it's like in our view, it was a cost worth paying, right? It was a couple percentage points. Yeah.
Just a question about the device correlation. You're correlating the terminal with the mobile device. And just based on the slides I saw, what you're using is, it looks like an IMEI or a device ID of some sort. Is that the only thing that you're using to identify the mobile device, or are you using sensor data or some other form of unique identifier?
Do you want to take that?
Actually, as far as that's concerned, we're just using device identity.
Yeah, we
That's
just use a hardware identifier for corporate issued purposes.
Okay. There's been ways to spoof that, so I was just wondering if there's some backup there or something.
Yeah, I mean, it's not necessarily one hardware identifier, right? There are, okay. So, in our internal deployment, the authentication is done via a certificate, right? In our cloud product, it's a similar technology, but it's not actually a certificate. So that's how do you actually authenticate the device to the cloud? There's a separate question, which is how do you do the correlation?
Yes,
right?
That's what I'm asking about.
There's a lot of ways to do correlation. It depends on whether you want to do self-registration or not. So, for example, mobile phones, Google mobile phones, Android has its own identifiers, right? Which is the identifier that we happen to use. It's created by the operating system and funneled up to the cloud. iOS has other identifiers. I think that CPUs, computers have different identifiers. So you just mix them together. I mean, I think, is there a theoretical risk of something like that happening in some specific situation? Maybe, but by combining enough different identifiers and sort of, validating it, I mean, we think that's pretty far down the hierarchy of needs problem.
But we're using multiple device identities, right? I think it's published in the paper that if somebody changes the CPU or a hard drive, suddenly access can be blocked because the identifier changes overall, right? And so it's not just one ID, it's amalgamation of hundreds of IDs from the device.
Just a thought, device, in addition to static device identifiers like you guys are using, oftentimes sensor data can be used for risk reduction.
Yeah, yeah, we're trying to be compatible with as many devices, right? Like a lot of them don't have sensor data, but it's a good idea, thanks. Any other questions?
Thank you very much.
Okay, awesome, thanks.